For question 1 by 3, I need to differentiate the following function with respect to x. So let's look at a first. If I want to differentiate my sine square, what I do is I treat this as chain rule. So chain rule means that I'm looking at it from outside to inside. So actually sine square, I can write it as sine x square. Okay. So I look at this as though I see two layers of function. The outside function, this is how I do differentiation. The outside function is like something square, correct? And then the inside function, there's the one on the inside. The inside function is basically sine x. Yeah. So dy dx, right? Basically, what I do is I just so-called I differentiate the outside function, multiply by differentiating the inside function. Okay, so the derivative, if you see that this is a bracket square, the derivative of the outside function is that basically 2 of that bracket then power 1. So in this case, the bracket is sine x, so we rewrite it, this is sine x. Okay, then differentiating the inside function, the inside function is sine x, you differentiate, you get cosine x. Okay, and basically you get 2 sine x cos x. Okay, and some of you may even write sine 2x because of the double angle formula. Yeah, next one is b. B, basically your y is tangent square of root x. So you can also say that you can treat this over, this is y, this is tangent x power half. I write this in index form so it's easy for us to do the differentiation. Okay, I see the first layer as the square. This is so-called first outside function, then this is the second layer, then this is the third layer. Okay, so if I differentiate the most outer function, so-called the first layer, the most outside function, this is going to give me so-called the outside function is like something square. So the power goes in front, power drop by 1. Okay, the next layer, if I differentiate the tangent square root x, it's going to give me secant square root x. Okay, and the next layer, if I differentiate x power half, it's going to give me half x to the power negative half. Okay, what remains is just for us to fill in all the blank. So this is 2 of tangent x power half, secant square x power half. Okay, so you just remember that we are differentiating layer by layer. Okay, I'm going to put everything back in third form. So this is the same as tangent square root x times secant square root x 1 over 2 square root x. Okay, cancel, and let's basically can combine everything. And we are done. Okay, next one is 1c. So 1c, we are looking at the derivative of square root cosine 2x. So basically 1c, we are looking at the derivative of square root cosine 2x. Okay, I can also say that it's basically the derivative of, if we differentiate something, it's really helpful to put it in index form. Okay, power, again, I see 2 layers of function. This is the first layer, this is the second layer, sorry, the third layer will be here. Okay, so the first layer, second layer, the third layer. Okay, so differentiate the first layer, power goes in front, power drop by 1. Differentiate the second layer, I get so-called negative, differentiate cosine, I get negative 2 sine x on. Differentiate the third layer, differentiating 2x, I just get 2. Okay, so this kind of trigo function is very complicated because there's a few layers. You can simplify, half and 2 cancel off. You have negative of sine 2x over cosine 2x. Okay, and this is for part C. Part D, we are differentiating y. Okay, y is equals to the cotangent to the power of 4, 1 over x. Okay, again, I see this as we have a cotangent 1 over x to the power of 4. Okay, if I differentiate this, again, I look at it as the outer function, second layer, third layer. Differentiate second layer, okay, power goes in front, power drops by 1. Differentiate the second layer, chain again, I have differentiating cotangent will give us a so-called minus cosecant square. Okay, then the next layer, if I differentiate, I have differentiating 1 over x, just give me negative 1 over x squared. Okay, then from here, my answer comes out to be, I just simplify my answers, negative 4 over x squared. So negative and negative will cancel off, there's no more negative. Cotangent cube 1 over x, cosecant square 1 over x, and we are done. Okay, for E, I'm differentiating basically cosecant square 1 minus 5x to the power of 7. Okay, so I see as again there's a, I write the power 2 outside. What I do is I write the power 2 outside. Okay, then I differentiate the first layer, second layer, third layer, and fourth layer. That's actually total of 4 layers. Okay, differentiating the layer 1, first layer, differentiating the first layer. The first layer is basically differentiating. This gives me power goes in front, power drops by 1. Differentiating the second layer, differentiating cosecant, give me minus cosecant, cotangent. Differentiating the next layer gives me 7, 1 minus 5x to the power of 6. And differentiating the last layer gives me negative 5. Okay, so I'm differentiating is I'm chaining the things outside and outside again. The first layer, second layer, okay, I differentiate, I get this. Differentiate the next layer, I get this. Differentiate the next layer, I get this. From outside to inside. Okay, and simplifying this, eventually you'll get a so-called 70, because 2, 7, negative 5, okay, negative sign. Okay, 1 minus 5x to the power of 6, cosecant square 1 minus 5x to the power of 7, cotangent 5x to the power of 7, and we are done. Okay, so next one would be part F. Okay, so part F, we need to differentiate. Okay, last one will be part F. So part F, we need to differentiate secant to the power of 5, x cubed minus 2x plus 1. Again, I see this, I put the power 5 outside. I see as the first layer is basically the power 5 function. Second layer is the secant, and the third layer will be the x cubed minus 2x. Okay, so if I differentiate the outside function, power goes in front, power drops by 1. Differentiate the next layer, I have differentiating secant gives me secant tangent, so it's like secant tangent. Differentiating the next layer, I get 3x squared minus 2. Okay, and we are almost done. Just need to combine the answers. So I mean, I need to write this at the front. It's good to write all the algebraic terms in front of the trigo terms. Okay, I put the power 4 in. Okay, and Yeah, and we are done. So if you want to actually combine this and put secant power 5, that's up fine, it's up to you. You can also do that. Okay, huh? Okay. So I mean I can actually do this, simplify my answer further. It's secant power 5 x cubed minus 2x plus 1 x cubed minus 2x plus 1. Okay, and we are done.